So the thing they give you goes out front, and now I just need to convert from grams to moles. Why am I going to moles? What's the purpose of going to moles? So I can use the balanced equation, right? So this equation right here that they gave you is balanced, and it relates calcium, potassium chlorate to, in this case, potassium chloride. It relates those two. There's 2 moles of this for every 2 moles of that. I can't use that relationship, though, unless I'm in moles. So that's my purpose for going from grams to moles. How do I convert from grams to moles? Where does that conversion factor come from? It comes from the periodic table. I don't have to use Avogadro's number, 6.022 times 10 to the 23rd, because that's converting from moles to atoms. I don't need that number. I don't need to go to atoms or particles. I need to go to moles so I can use the equation. So all I'm going to do is take my periodic table, look up the weight of those individual elements. Potassium is 39.1 grams. Chlorine, if you look that up, that's 35.45, right? 35.45. And then oxygen is 16, but there's 3 of them in this molecule. All right, so that's 48 total. If you add all that up, what did you get? 122.55. All right. Awesome. So that weight goes right here. Why did I put this on the bottom and not the top? Because I want to cancel the units. Exactly. So I want this gram unit to cancel and leave me with 1 mole of potassium chlorate. I could have written this conversion factor the other way around. I could have put that weight on top and moles of calcium chlorate on the bottom. I need you to recognize something here. There's only 2 ways to write this conversion factor. It's a 50-50 shot. You can get it wrong, right? You could use the wrong one and just recognize what kind of units you're going to end up with. So for example, answer me this. X times X, what is that?
X squared.
Okay. X over X, what is that? It's 1. The X's disappeared, right? They didn't disappear, but they became 1. So X is no longer an issue. What's grams times grams? Grams squared, right? What's gram over gram? 1. That's what we're doing here. We're saying grams of potassium chlorate over grams of potassium chlorate is 1. It's no longer an issue, and my unit right now is just moles of potassium chlorate. What's up, Eric?
Wait, so if you want grams, you
Yep.
just go 1 mole over the atomic weight, right?
Absolutely.
And then if you want particles, you go the other way around.
For particles, all I would do is say 1 mole is, after I convert to moles, I'd have to say 1 mole is 6.022 times 10 to the 23rd atoms. So right now, from right where I am right now, I'd have to multiply by this. 1 mole of potassium chlorate is 6.022 times 10 to the 23rd atoms. If I wanted to go to atoms, that's what I'd have to do. Right? Because now my unit, you can see, is atoms, and I've canceled moles of potassium chlorate. Make sense? Okay. So don't do that step on this problem anyway. Everybody with me so far? So right now my unit is moles of potassium chlorate, and I'm trying to go to grams of chloride. That's my goal. So how do I get to grams of chloride, potassium chloride? What's my next step, Allie?
Would you do 2 KCl over 1 mole?
Very close. Very close. Exactly. So if you look at this relationship right here, I'm going to say that every 2 moles of potassium chlorate, 2 moles of potassium chlorate gets me how many moles of chloride? 2, right? So 2 moles of potassium chloride. All right. Now check out the units. Get in the habit of doing this for yourself. Okay? Look at these units and notice that they cancel and scratch them out. Moles of potassium chloride is gone. And I'm left with moles of potassium chlorate is gone, and I'm left with moles of potassium chloride. Everybody with me so far? I'm at moles of potassium chloride. The question isn't answered yet just because they asked me for grams. That's why I know I'm not finished. That's my goal for the unit. So the unit should be grams. I'm not there yet. What do I have to do to get to grams? I have to convert to the weight. How do I do that? In the periodic table, what is the weight of potassium chloride? All right, so if you add 39.1 and 35.45, I'm going to screw that up because I'm dyslexic. You get, what'd you say, Sturge? 74.55 grams of potassium chloride. So that number, I'm going to put moles or grams in the denominator? Moles. Because why? What's my purpose? I want to cancel those units, right? So 1 mole of potassium chloride from the periodic table weighs 74.55 grams. So this is my last step. Because I'm now in grams, I'm finished. All right, so write that again, just so you can see the units better. 74.55 grams potassium chloride. Now I'm finished. Moles of potassium chloride is canceled. Those are gone. Moles of potassium chloride there's one in the numerator, one in the denominator. They cancel out. All right, so in your calculator, this is what you're doing. You're taking 5.3 grams, dividing it by 1 over 22. Does that math make any sense? Okay, so look, 6 times 1/2.
Oh,
Hold on, seriously, 6 times 1/2, what is that? What is it? 3. What's the operation you did in your head, though? Division. So what you're saying is 6 times a fraction, that's division, yeah? So this is the same thing. 5 times a fraction, 1 over 122, that's really 5.3 divided by 122, right? So in your calculator, 5.3 divided by 122.55 times 2 divided by 2 times 74.55, that gets you grams of potassium chloride. Everybody all right with that?
What was that? Times what?
The last step is just times the weight of potassium chloride, so 74.55. Somebody put that in your calculator, tell me what you get.
3.224.
Okay. 3.22. And that's grams potassium chloride. All right. So that's the first one. Let's do D. Okay. So for D, they're giving me the same amount to start with, 5.3. Actually, here we go. Let's be fancy. So they give me the same starting amount, but they're asking me for liters of O2. So I can take all of these steps right here, converting to moles of potassium chlorate. All right, so I can take those steps. That's my first steps here. And now all I have to do is go to moles of O2 using the equation. So how many moles of potassium chlorate are there for how many moles of O2? So there's 2 moles of potassium chlorate for every 3 moles of O2, right? You see that? So in my conversion factor right here, I'm going to write every 2 moles of potassium chlorate gets me 3 moles of O2. And that's straight from the equation. Do you notice that these units cancel? Moles of potassium chlorate, they're canceled out. I'm left with moles of O2. They want to know how many liters of O2 that is. And there's one conversion factor I want you to write on your periodic table, and that is this. That at standard conditions, okay, so at standard conditions, at STP, 22.4 liters of gas, any gas, is 1 mole of gas, whatever that gas is. All right? So what I'm doing here is I'm asking you to use induction. All right. So you're supposed to be able to see this specific example of how to convert units, make a general rule, and then use deduction and apply those general rules to something specific, another new specific problem. Right? You guys have heard of induction and deduction before? So this should show you a general principle that you should then be able to apply to a new problem. So you've never done this conversion before, but you should be able to figure out how to cancel these units. If I want to go, Davin, what do you think? If I want to go from moles of O2 right here, and I want liters of O2, and I know that this relationship exists, how could I do that? What would I write right here for a conversion factor? I want to cancel moles of O2 and end up with liters O2.
Does 22.4 have to be in there?
Yes. Yep. So you're going to use this relationship right here.
On top?
Good. You're going to put 22.4 on top?
Yeah.
Okay. So 22.4 liters of O2. How many moles of O2 is that?
One.
1 mole, exactly. So 1 mole of O2 is 22.4 liters. Sorry about that.
I got you, Mr. S.
All right. So now you can see moles of O2 cancels. There's one on the top, there's one on the bottom, and I'm left with liters of O2. So in this particular problem, this is what you'd put in your calculator. 5.3 divided by 122.55 times 3 divided by 2 times 22.4 liters gets you liters of O2. So I threw a new conversion factor at you, which made it so that you had to use that deduction, right? You had to take that general principle of how to cancel units and use it on a new type of problem. That's something you're going to have to do for your competency.
I'd like to, and then multiply the 22.
Yeah, because that's in the numerator, right? That's going to be multiplication.
I have it.
What do you got?
Not sure if it's right, but it's 1.45.
1.45? Okay,
Yeah.
nice.
It
That
goes
sounds
on.
good.
That's right.
1.45, and that's liters of O2. Make sense? All right, so take a peek at this problem set. Yusuf, could you hand this up? This problem set is what your homework quiz tomorrow will be on. All right, so I'm not going to grade this homework quiz for today. We just went over it together. Hopefully it's making more sense. Work on this problem set. I'll post answers tonight after school. Check in with it all. Make sure you can do it correctly. I'm going to take one problem off of this, and we'll do it tomorrow for our homework quiz before we do our lab calculations. All right, so tomorrow, if this homework quiz goes well, we're going to do our calculations for the lab. The lab is this. I'm going to give you these two solutions. I'm going to give you one solution. I'm going to give you sodium hydroxide, and I'm going to give you enough copper sulfate pentahydrate to run the reaction. I'm going to give you a specific amount of copper hydroxide. I'm going to tell you I want exactly 0.03 grams of copper hydroxide. How much of this do you need to make that happen? If you had excess NaOH. That's a lot like the problems we're doing right now. All right, this is a balanced equation. No, it's not. Never mind. Now it's balanced. Okay. That's a balanced equation. I'm going to give you an amount of this. I'm going to say you have 0.02 grams of this, 3 grams of that, and you're going to have to figure out how much of this in grams you'll need in order to make that happen. You'll measure it out. You'll add that to sodium hydroxide. You're going to produce this, filter it, weigh it, and it needs to be right on the money. And your percent yield is going to be your test grade. So after you produce this stuff, you filter it, you weigh it. It should weigh exactly this much if you were correct with your calculation. Right? And that's going to be your grade. So work on this problem set. These are exactly like the lab calculations that we'll run tomorrow. You want me to run you through the first one just to start you off? Okay. Okay, so here's number one for the new problem set in front of you. So this is a really simple one because they're just asking for one conversion. Definitely, yep. They only want one conversion. They want you to go from moles of nitrogen. They give you 2 moles of nitrogen to start off with. So 2 moles of nitrogen goes out front. That's what they're telling me I have. That's my sample. They want to know how many moles of hydrogen I have. So all I have to do, because I'm in moles, can I use that equation? I can. That equation is in moles. So I can use moles to relate nitrogen and hydrogen together. So how many moles of nitrogen do I need? In this equation, how many moles of nitrogen do I have for every how many moles of hydrogen do I have? So 1 to 3. So 1 mole of N2 to every 3 moles of H2. I took that right from the equation, right? There's a 1 right here that's implied. That goes there. And there's a 3 here that goes there. Why did I put moles of N2 on the bottom? Because my goal was to cancel that unit, right? So that's why I did that. That was the reasoning. And now I'm left with moles of H2, which is what the question was asking for. So I'm finished. That's my only step here. As soon as you get the units that the question's asking, you're finished. So in your calculator, that's just 2 times 3. This is 6 moles of hydrogen. Is that super easy? Okay. So that's a fundamental type of conversion. This right here is called the mole ratio. I'm comparing the moles of hydrogen in this expression to the moles of nitrogen in that expression and using it to convert between, from one to the other. What's the only other type of conversion factor I'm going to have to use in stoichiometry? Where does it come from? Periodic table. This is how I go from grams to moles and moles to grams from the periodic table. How do I go from moles of one substance to moles of another substance? Use the equation. If you want to go to particles, which I may ask you for, now you use Avogadro's number. Yeah, Avogadro's number. But you're not going to have to do that very often. It's not very practical as something to do in the lab, right? Because atoms are so small, you're not going to ever really be able to count them, right? So if you don't finish this today, do it for homework. And there'll be a homework quiz tomorrow, beginning of class. If that goes well, we'll do the lab calculations. And that lab will be a test grade, okay? It's a summative.